What's up, those in Texas? Chilling. Hope you're having a Gucci day. Whatever, something like that. We're going to get started. This is section 4.6a, okay? 4.6a. The homework that we're going to do is online. We're going to give, this homework will be due on Tuesday. So just a heads up on that. And then the quiz for all of the graphing ones will be on Tuesday. We have one more new thing to hit on Monday, and then we'll go from there. Cool? All right, sweet. I don't know what just happened. Man, it's the rock. It's my rock. Okay. So let's get started. I will tell you this. The ones that you see on the sheet that I gave you, again, this is all of 4.6, okay? David Murphy had a really good point, and I thought was really good critique, actually. I'm going to try to do a better job of providing numbers on these so that it's easier to go back to. It's a little bit, all the homeworks I create, so I sometimes just am trying to add some things to it.
Is there any way there could be more space to work out the columns too?
I'm going to do that. These ones I didn't provide it because you would do all the work on the graphs anyway. But the other ones that I did provide, I tried to do the best I could to give the adequate space that's there. But you're right. So the ones that we will show on here, I will definitely provide space and provide numbers and values and all that. Hopefully make them better on that. But the ones that we're going to do, the ones we can do, are on the far right side. The ones that say cotangent or tangent, just ignore. We can actually put those off till later. I figured we could do at least one together. Claire, yesterday what we did was we just went through the homework. So we just did homework stuff. So the goal of today is, let's go through cosecant and secant. And if y'all are like, hey, could you just, and the last class did this too, they said, hey, coach, 3 or 4 of them were like, hey, could you show us a cotangent one before we come back on Monday so that we could kind of have an idea of what we're doing when we come in on Monday, which is perfect. We can do that too. Well, let's take a look at one of these, and then we'll go from there. Any thoughts on, first of all, we did one of these, right? Or just briefly?
I think we talked about it.
Just briefly? Okay. So remember with the cosecant graph, what are we really graphing on this? The reciprocal of it, yeah, which would be?
1 over pi 6.
Well, that's actually a good thought. Well, when we graph it, we're only doing the reciprocal of cosecant, which we're going to graph sine of that same thing. You remember that? We kind of said we're going to graph sine first. With secant, we would graph the same thing, except we graph cosine first. Okay? So it's kind of fun because it's literally the same thing we were doing earlier. So let's go through the steps here. Amplitude, period, and phase shift. And if there's a vertical shift, we list that too, but there's not in this example. Give it to me. What do we got? What do you know?
1 is the amplitude.
Nice. Good. 2 pi over. This is tough.
Oh.
I actually did not even recognize this. What's the tricky part about this?
Oh, it's switched.
It's switched there. Do you see it?
Yeah.
It's -1 that's attached to it. Okay.
Why? Normally the x would be on the left, right?
Yes.
Yeah.
Yes. I didn't even. I don't know what my mind didn't even think about that. Let's do this. Let's try to talk over the period then. What would be the period? What would be b? How about this example? -1, right? So it's 2 pi over -1, which is? -2 pi. Here's the kicker, though, with period. We're only going in the pi. If I go -2 pi to the left, I also can go -2 pi, or positive 2 pi, right? So period, it's not as much as the positive negative as the distance. Cool? So I'm going to keep this as positive 2 pi for my period. Is everyone clear on why that's the case? If I go 2 pi to the left from wherever I start, and I go 2 pi to the right, that would be the same thing. Cool? The next part's probably the tricky part. What would be the phase shift here?
1 over pi.
Yeah, so it would be c over b, right? So pi is c over b, which would be pi over -1, which is negative pi. But if there's a negative in the inside, we know it's going to do what? It's going to be positive. So the phase shift would be positive pi. That was just enough of a little bit of a switch to just kind of throw a little wrench into it. But does that make sense on how I would approach it? Cool. So again, we do our same thing. think all of us do the same one from when I was kind of checking around there. We do the 4 spaces and then just kind of keep it consistent there. The amplitude we know was what Claire said, which was 1 and -1. Now with sine, with the period being 2 pi and the phase shift being pi. All right, Madeline, you ready? You're gonna help me out? Is it cool if I ask you? I just want to see if you do mess up where it is. Is that
Okay,
cool?
yeah.
So where do we start?
So we're gonna do 2 pi times 1/4.
Good.
Then we get pi over 2.
Pi over 2. I like it.
So is that the first x?
Well, not. What's the
Or do we?
line
No,
of
we added. I'm
scrimmage?
sorry, we added to pi.
Yeah, the line of scrimmage is my pi, right?
Yeah.
So I'm gonna put pi here.
So then we add.
That's gone, right?
Mhm.
We're not touching that or the amplitude now.
So then we add pi over 2. I mean, yeah, pi over 2 to pi.
Nice. So we'd say pi over 2 plus pi, right? So we have pi over 2 plus pi. And what do I do in order to add those two together?
Denominators.
Which
so
would be?
2 pi over 2.
Nice, which would be?
It'll be 3 pi over 2.
Nice. So we're going to put 3 pi over 2 down here. Okay.
Alright, so now we add 2 pi over 2.
Correct.
Okay.
Good. Good.
You had 2 pi over 2, right?
Yep, right there. We add that again, right? Claire, are you with us on where we're at? I know you weren't here yesterday.
Not really.
We did something new yesterday that I felt like was helpful. Instead of going to pi and adding 2 pi, which was our period, to get to my ending point here, you could do that. Pi plus 2 pi is going to be what?
Wait, what?
So pi is where I
Oh,
start.
3 pi.
Good.
Yeah.
So 3 pi is going to be my ending here. Okay? Hold up. Hold up. Did I?
That's what I got.
Okay.
Dadgummit, Madeline, I did it again. I did what you did earlier.
Oh my gosh.
What happened?
I did what you did. Okay.
We had pi over 2,
Yes.
not 2 pi.
Yes. Madeline's now transferring it to me.
Why do
Okay, so wait. That whole thing we did over there is wrong.
No, you were right. You were right. I know that for a fact. You added the right one. You added the right one because that
Oh my
because the period was 4 pi. You divided by 4 to get pi for that one. To get pi, so you added pi to each time. You all were right with that one. 100% on that one. I know.
So don't
This
add
one-
the common denominator
No, I can't. Well, I can't say that. Okay.
one.
Here's what I would say.
Wait, what?
Whatever one. Okay, hold up. Whatever one I divided by 4 by, that value. Maybe this is where we're getting struggling. Me included. Okay. Whatever one we get here, when we add it, that's the one I'd circle. The one in red circle is the one that I'm going to continue to add. Remember,
Yeah.
we were adding 2 pi over 2.
That's what, yeah.
It's like, what am I doing? It doesn't make sense because if I started at pi and added 2 pi, my ending should be 3 pi here. Okay? Cool?
How do you
I'm not.
get that top
Good question. I take my period of 2 pi. Okay? 2 pi is this distance. Do you follow me?
Yes.
If I divided that by 4 or multiplied by 1/4, 1/4 is literally 1/4 of this. So we say that the distance of that right here is going to be 1/4 of 2 pi, which is pi over 2.
And then you just continue.
Just keep
to
adding by
that,
pi
so you
over
get
2.
each 4.
So then
Correct.
Okay.
What we messed up on, me included, and Madeline we were struggling with this yesterday, was she transferred it to me, but that's okay. If you add pi, we get 2 over 2, right? This is not what I keep adding, because this was from the original,
You keep adding.
pi over 2.
Okay.
So this would be, this is right, 3 pi over 2, but then we'd have 4 pi over 2, good, and 5 pi over 2, and then 6 pi over 2. And if you've already got that groove, why not just continue? 7 pi over 2, and so on and so forth, right? The only thing I would be careful on is remember that one graph is going to be in this area, right? So if this is sine,
Wait, so when do you use the one with the common denominator?
this one,
When you're
Yeah.
adding.
Yeah, the only reason why I got a common denominator here because this was the pi.
Well, yeah, I know, but when do you use it to go off the basis of adding? You like she was like, oh, so don't use it. You were like, I can't say that.
Okay, side note. Okay, cool. Just I'll give you an
Okay,
example.
Okay.
If I started at pi over 2, right? And when I did 1/4, I got a common denominator, or I got a distance of pi after I divided by 4. I would be taking pi over 2 plus pi to get to my first spot. So I'd get 2 over 2. Got me? What am I going to continue to add? 2 pi over 2. Where in this context, what one am I adding? I'm adding pi over 2.
Okay.
That.
I'll catch on.
So I just gave you an example of you can't always say that it's this one or this one. It could be either. Cool. What I would say is circle the one that I multiply by 1/4 by and know that that's what I'm always adding. Cool.
Okay.
All right.
So you to get what you add to get the points. What do you take? You take
The period. Mhm.
and then just multiply that by 4.
1/4. Because that's the distance. 1/4 each. It's like each quarter. Cool. Y'all get how to graph it from here? Y'all are good from there?
Yeah.
And then come down, right?
You can put the other lines in.
Yeah, so now what do we do? What? So literally nothing changes, right? Except one thing.
Put the lines through the X's.
Yes, it's always the x-intercepts, right? So it's up and down, up and down, up and down, up and down, up and down like this. And then we just, wherever, if it's up, we put it up. If it's down, we put it down. So technically, the ones in yellow, that's the graph we're looking for, not the one in red.
So that's the secant graph?
The secant graph is the one in yellow.
Oh.
That's the only difference. So the red part is, if it was a cosine graph, that's what I would do. The only difference is wherever it hits the x-axis, and that's the same for secant or cosecant. We make the asymptotes, and then we make parabolas up or down. Okay? All right? I feel
Would
like
that
we
be
need
the
one
same
more.
for
'Cause
cotangent?
cotangent and tangent are different.
Okay.
Okay? I think they're easier to find than sine and cosine. They're just but they are different.
Okay.
So I keep that as it's completely separate. Okay, completely separate on that. All right, y'all want to do one more? Okay, let's try to see if we get. I can do this one right because I know I messed that last one up. All right, so what's the amplitude?
2.
2. Let's put that there. What's the phase shift?
The period is 2
Period's 2 pi. Good. Yeah, I usually go in. Yeah, I went out of order there. 2 pi is the period. Phase shift is pi. Positive or negative? Negative.
Wait.
Yeah. Let's go to the left side, right? So I start at, over here, I start at negative pi. Good. And here we go. Before I do this, I want to make sure I take my time here. Sure we go from here. All right, so there's our first period. We know it's negative pi. Period's 2 pi. All right. Madeline, what are we going to do on this one?
So 2 pi times whatever.
Good. Claire, are you good on that?
Yes.
Yes. Why did we multiply by 1/4 again?
Because there's 4 points.
There's 4 parts, right? So a lot of times people struggle with the quarters. If you wanted to, you could just find the halfway between them. That's a little tougher, I think. I think this, once we get this, I think it'll be better, easier to do. Just make sure the distance between here and here is the distance of the period, 2 pi.
Okay.
So real quick, I've got a question. Just before we go any further, where would the ending be? Before we get started with each of these points.
2 pi.
The distance would be 2 pi. 2 pi from negative pi would be positive pi. Good. You track that?
Yeah.
Because you're traveling that, right? Okay, go ahead, Madeline. What do we get?
Oh, yeah, so then it's pi over 2.
Cool.
So we add, we do negative pi over 1
Mhm.
plus pi over 2.
Nice.
Common denominators.
Good.
So then it'll be pi over 2. So that's our first point.
Okay. Did you say positive pi over 2 here? Good.
And then we do negative pi over 2 plus pi over 2.
Nice. And I think it's as simple as just maybe circling it or doing something. Just say, all right, this is the one I'm adding each time. You know. So what would you get?
It's going to be 0.
Nice. What's the next one?
Pi over 2.
Nice. Good. And with secant, how do I graph that one?
That's
Graph it
cosine.
like a cosine.
Cosine. Good. Up, down, or through?
Down,
Start up, but
Oh.
yeah, start up on the.
Start it on the
yeah,
top.
start right there and then go
Start it
down.
on the top, and then we're going down, right? I think if you said that or meant that, that's fine. So we're going down through X, right? Where does it hit the middle?
0.
0. If you struggle on, how do I do that? It may help you to know that wherever I start is where I'm going to end, right? And then that way, when it comes down, then it comes back up through the X, and then it hits on that top side there, okay? And then it just should continue, right? Just continues there. Boom, hits the bottom, goes back through the X, hits the top, okay? And then I just need those dots, right?
Just make the lines through the dot, your dots.
Yeah, and I also need these two right here, right? These two?
No, I mean through the X's actually.
Yeah, we are going to go through the X's, good, but we need to label these before we do that, right?
Oh.
Or you can do that at the end, that's fine. But what would these two be labeled as? This would be 2 pi, and then this one would be 3 pi. Good, good. You probably could just see it too and see what's the distance between 0 and pi. It's pi, and then just keep adding it. I like it. Claire, what do I do now to graph it? In the
So
secant
you go
part?
to the top like arcs,
Mhm.
and you flip it. Go the other way.
So I go this way?
Yeah.
Good. There's one thing Claire's missing. What's the one thing?
The asymptotes.
Yeah, the asymptotes are important
Okay.
because that's what the parabola stays in. Like it stays between the
Okay.
asymptotes. It's here and here and here. Just make sure it's through the actual x-intercepts, not the dots, through the x-intercepts, okay? All right, is that bad? It's not too bad, right? Cool. And I think I finally figured it out. We're good. I love it. I love it. I could see how that could be confusing. I like that method, but I could see how that could be confusing. There. On that. Cool, cool. If y'all want to do another one, y'all can. We get out at
05.
we have 4 minutes. So if you want to do one more, you could, or
Let's look at another back.
do that. Another bet.
Shit,
What did you do in math class today? Well, we were discussing probability, and we were betting.
I mean,
Dude, I said
three
I
on
was
the
like,
top.
I'm starting on the varsity team, but I nailed it right before I left class yesterday.
I did not say anything though. Did not say anything.
Shit. I made 3.
And I just got that on the podcast.